Howdy. Wow. Okay. We're getting better. All right. Very good. You guys are teachable. How many went to the little gala we had last night? What'd you think of that? Yeah. Aggie Wranglers. Yeah. The Corps of Cadets. That was fantastic. So I'll tell you a little bit about what we're doing today. We've got our 8th panel today, which is the future of interoperability. And we're going to talk about AI, digital twin, and IoT. Then we're going to have a keynote by Charlie Gademi from DC. And then another panel on resilient communications, PACE planning, followed by lunch and vendor expo. So during lunch, again, please make use of the vendor expo out there, get to know what all these vendors have to offer. And please also take time to meet yourselves. Remember, I mentioned on day one that we have over 100 organizations here from a variety of different public safety organizations from local to county to state to federal to even international. After that, we're going to go over to Disaster City. How many people are heading over to Disaster City today? Fantastic. Okay. So on day one, I mentioned that ITEC has an amazing lab and an amazing staff, but we're part of much bigger system, right? We've got the Texas A&M University and then the Texas A&M University system. TECS runs the Disaster City area, and you'll get to meet another state agency there and another facility. So we're really able to do so many things with research facilities on campus, in the academic labs and high-tech lab, the Disaster City area for simulating disasters and public safety training exercises, things like that. And then the RELIS area for kind of more open air and instrument to touch range. How many people went to RELIS yesterday and saw the tour there? Okay, pretty amazing stuff there. Unfortunately, we had some bus snafu, so we didn't get to go into the security and the ring, but I think everything else that was there, I heard a lot of confidence on that they have the capability to do there. All right, so that's today. After we get to Disaster City, the technology training is going to occur. So what we're going to do is take everybody through the various technologies that are going to be in use on Thursday. And the idea is so the first responders don't get handed a device and say, okay, now go do your job and somehow figure this out at the same time, right? So we're going to take you through, here's how MCPTT is working. And even if you've used it before, here's how we're set up for our event, which talk groups we're using, which and what purpose each talk group has, things like that, how you can communicate between the MCPTT devices and radios, things like that. We'll take you through how we're using TAC. If you have your own personal device, if you're not one of the responders and you want to get TAC on your device, we can help you with that. And that way you can follow along and see everything that's going on at the exercise. We'll take you through WebUOC, we'll take you through all the different technologies that are being used at the exercise. The last hour, we'll do a little preview of what to expect on Thursday. We don't want to give away all the secrets, but everybody will have an idea of what's going to happen in what sequence. And I think you'll find that interesting, even if you just want to observe that. Following that, I think we've got dinner served there, and I don't know if it's barbecue or something like that. It's a pretty informal center this time. Okay. Any questions so far? Any? Let me ask. What kind of aha moments or something you just didn't even expect to learn? Tell me something you've heard this week that just like, wow, I didn't know that, or wow, that was interesting, or something like that. Yes, sir.
I was really impressed with that concept of a 911 call, including a video of what's going on.
Yeah.
That's brilliant.
911 call with video, fantastic. Anybody else? Yes, sir.
I was a little bit blown away that we had a process and Allison ran on that team where all the IoT devices were being addressed and the data captured automatically, and then they were kind of figuring out what it was without knowing anything about those IoT.
Exactly. Capturing the IoT device information, figuring out what kind of sensor it is without knowing in advance. It's really cool. Anybody else? Yes, sir.
I have to say that I've never been here before, and I'm just in awe.
General law.
I might be the first Aggie from Pittsburgh, who knows?
First Aggie from Pittsburgh. Love it. Okay, so we are going to start off our first panel for this morning. The future of interoperability, talking about AI, digital twin, and IoT. And where's our moderator? We'd like to welcome our moderator, John Merrill. John spent 28 years, he's a 28-year veteran with the U.S. Coast Guard. He worked in program and policy management, radio navigation, maritime law enforcement, search and rescue, vessel traffic services, and telecommunications. He was a senior policy and technical advisor for DHS on GPS interference, detection, mitigation, and radio frequency spectrum management. He currently serves as the acting director of Department of Homeland Security First Responders and Detection Division. That oversees 4 key operating areas. One is countering weapons of mass destruction office, the Federal Emergency Management Agency, the Federal Law Enforcement Training Center, and first responders. And he's director of the Next Generation First Responder APEC program, which developed and integrated cutting-edge technologies, allowing for a timely, efficient, and safe response to disasters of all sizes. One of his primary missions is to advocate on behalf of first responders, encouraging industry partners within the program to collaborate directly with responders on research, development, testing, and evaluation. And I'd like to welcome John Merrill. Thank you.
Listening to that bio, the job, believe it or not, 3 years ago. Right now, I'm the technical director of the Technical Services Division within S&T, and we are the research and development arm of DHS. If I could have my panel members, if you want, you can sit where you are, and then you can call, you can go ahead and do this. But before I do that, quick panel introduction. You have Peter Kyle, maybe you already met. He's going to be going over some things related to the digital twin work that he's doing, and Dr. Robin Murphy, who's very well known for robotic work on the research in space. And then Darren Ludington, Singapore Technology Center, Direct, 20 years experience on SATCOMs. Now, to set the stage in terms of what we're trying to do, remember, talk about the future. The past couple of days, we discussed a lot of things that are happening in the responder. So what this future interoperability will look. Stated a slightly different way. All about taking it from interoperability, network, strategic futures. The reason I bring that up is that that's a key area that we are doing with respect to ICT. We're so interested in this, we partner with Department of Defense, and we actually created a position that looks at strategic futures. What does the technology look like? So you've heard of Gartner, you've heard of Sullivan, White, what we call the think tanks in the Washington, D.C. area. They do the same thing. So what we're looking at is from the perspective of the responding community as a whole, what could that potentially drive in terms of what we're trying to do here? What I'd like to do is show one quick video, and then after that, then we'll start with it. that video under my former position as the next generation person on the program. The concept was discussed 9 years ago, and the video was actually produced 8 years ago. Just to give you an idea as to what we're trying to do and the direction that we're going. It kind of sets the stage because I think it extracts some of the things we've been discussed today with the panel members of some of the concepts that we were discussing back 8 years ago to bring forward today, which some of you are already working on. And hopefully we can move forward in that direction to address, to make sure that we can get that full end-to-end interoperability. With that, what you do? Thank you. Yes.
Good. All righty, howdy. Well trained. Good job, you. Could we get this to show up on this monitor? We don't have to. All right, well, anyway, I'm gonna go fast. Lots of graphs and charts to talk about drones and wireless. So first off, I'm just going to put in a plug for the fact that I'm, besides being a professor here with Texas A&M and working with the Center for Robotics as a Search and Rescue, we have an NSF. We have an NSF AI Institute led by Carnegie Mellon, Howard, Harvard, all these other groups focusing on societal decision making. So our concentration is on data to decision, getting the right information to the right person at the right time so they can make the right decision. All right, so just a quick look. We're seeing hurricane. I'm going to give you examples from Hurricane Ian. It's the 22nd disaster with drones that I've been in. And that's been our Center for Robotics Assisted Search and Rescue. We started flying in 2005 at Katrina. But all the data I'm showing you is now more quantitative, but it's everything we've seen before. And some of you have probably seen the basic takeaways. So if you're into drones, you're trying to figure out what's going on, you fly a drone, the responders fly a drone, and the first thing they want to do is get video, short, small video, maybe do some streaming images. Where are the people who need help, the rapid needs assessment, how to get the responders there, what roads are open, how are we going to do this? And then we come in and start doing damage assessment. So that's going to be the mapping. You'll hear the phrase orthomosaics a lot, huge files that get shipped around. Huge files made up from lots of many huge files. Okay, now in terms of communication, network communications at Ian, we had at the forward operating base. So that's the place at the front edge of the response. First thing you see is that we had at Ian 6 different options. Plus we had the wireless option of war driving, where I got in the car because none of the 6 options were working with crap. And then it turned out that the Interop was up over at Florida Gulf Coast. And then finally we gave up and just started every night driving to Collier County, which was a 2-hour drive. All right, let's see why that is what it is. So this is a chart. Look at, you're seeing day is on the bottom, the x-axis. We're going on upload time. We don't care about upload. We're trying to get information to the right people. We in the field pretty much know where we are. All right, we've got, and the gray bar there that's showing up is Starlink's max, depending on what day you read their literature, about 9 gigabytes per hour. And you see it starts out low, gets higher, and day 3 gets really, really high. Now the green bars are the best we ever saw. Yellow is the average. And you notice on the first day, we didn't have any meaningful connectivity. So the good news is that, the first 2 days, you're not needing as much as you do later on day 3. So it gives you a little time to get in position, sort of. The bad news is look how bursty, that's by hour. So look how bursty the data is, which makes sense. You get it about in the afternoon, and then you get it right in the evening when all the crews are coming back. All at once, everybody has gigabytes. Yes, 60 gigabytes of data to upload. And if you try to upload from the field, remember it's 10 to 20 miles away from the nearest generator, which are where you're going to put a FirstNet truck in there. Now, if you look a little bit more, again, let me emphasize the gap between the best we saw, and we were next to the FirstNet truck. Okay, next and connected to the this is still the best we could do, right? Huge gap, huge gap. All right, now let's see why do we have these gaps? Why do we have those spikes? We see this every time because the first couple of days are all about that videos, images mostly. Give me pictures. Let's see how bad it is. Who needs help? Where are they? Get that up. And sometimes you don't even bother. It's just calling in the location what you're seeing. Then we shift to that damage assessment. You're not worried as much about, you got everybody out of harm's way. Now we'd like to get the government to pay for it, to reimburse us for the cost. And then we start going for the lower hanging fruit. But it's basically the first 5 to 7 days. The first 3 days are critical for life saving. It's day 3, you really start seeing interest in mapping and sort of mosaics. And again, you superimpose that over what we saw there. That kind of explains what's going on. Okay, now let's make this problem worse. Okay, let's just take day 2, which wasn't day 3, right? Really bad, right? But day 2. Now let's flip that over, and instead, now we're going to look walking away from the microphone. Now. So that's time, and we've just made that into look like a pipeline.
There's a hand mic if you want to use it.
Oh. Thank you. So did we say artificial intelligence for natural stupidity? All right. Great. All right. So you see the pipeline. So what's happening is as soon as we start coming in, we can handle the early morning high priority. You send them at a dog, they come back as soon as they humanly possibly can. And then after that, we get a huge backlog. We can't upload fast enough. So we are sitting there till literally about midnight when we go over to the EOTC. Okay, so just some things there. Now, and of course, I'm going to make it even worse because not only do we have all these files that we're trying to do the cloud processing on, and we're trying to move things and getting the right things to the right people. And we would like, right, as a data decision, is to start simplifying some of that decisions by doing things like counting the damage, actually using the FEMA categories so it can get your reimbursement on damage, and also remember that part about roads, what roads are open and not. So we've been doing a lot of work with AI, but okay, there you go, cloud computing, once again, a lot of transfer and stuff. So to summarize, the bad news is, what I want for Christmas is 60 gigabytes an hour of upload capacity, please, sir. That would be great. All right. The data takeaway is the data is bursty. When you talk about setting up a bubble, give me 10 to 20 miles. That's what's going to be. What we have from that nearest generator. Day 1, no reliable wireless. Day 2, we've already started to exceed demand. But day 3. And that is always going to be the way that day 2 or day 3, we're suddenly going to go to damage assessment. We're really going to start sparking up every ounce of bandwidth. Okay, and it's only good. But the good news is you got a day to get in place. That high resolution mapping and digital elevation maps that you're going to see at the exercise tomorrow are really 2 to 4 times more data than you would see on the first day or 2 of an incident. And you wouldn't see that during an actual active shooter or building collapse again. So if you can handle it, for this exercise, great. You're really positioning yourself well to handle it for the rest. And just remember, we're trying to do research in edge computing, trying to push as much as we can down to the edge so that we're only having to use the network for the supercritical stuff, the high value information with it. All right. We got that, and the other good news is we're here, so please help us help you as researchers.
Hey, howdy. So my name is Jian Hong. I'm assistant professor from the School of Homeland Security and Fine Arts. And I'm also assistant director for project development at the Texas Institute of Data Science. So we started creating this digital twin lab 2 years ago. That's about time when I started joining this Texas assistant professor. And I was pulled into this public safety community by a single phone call from Walt. And he single-handedly got me into this community. And I was mostly doing numerical simulations, data analytics, and I was a trained astrophysicist. But starting from this phone call, we started looking into different scenarios that could be helping public safety community, especially for the communication and network related projects. So this is one of the projects we worked together 2 years ago. It's almost 2 years now. And the idea was to put together a platform, which is digital twin based, to help first responders test their communication devices, build a platform to enable interoperability into somewhere and test it, digitally actually. So we started working with TIC folks. The last city is our primary target for the physical twin. Whenever you build a digital twin, you need a physical twin. Otherwise, it is something working. It's different. You probably don't call it digital. But with the physical twin there, we needed to figure out where to install the sensors, how to do that, getting all the budget figured out. And then we work also with ITEC to figure out how to set up, the network, how to get everything configured, get all the data transferred between the other city and the main campus, and also across other units here on campus. So on the development side, we have digital twin planned, designed, planned, and also executed, mainly by very interdisciplinary collaboration. So folks from our school, mostly doing game design, training, animation, and IM has some of the best animation program here in the US. And we have trained tons and tons of students to do the game design. To me, it's kind of a waste of talent. A lot of talent, skills that are being trained and could be used for science, engineering, and all the public services. So I tried to bring some of those talents into this field and get them started. And some of you probably have seen my students yesterday, and they are working hard on this. And also we have folks from engineering and a lot of work on AI, machine learning, IoT, edge computing, cloud computing, high-performance computing, all those got involved into making this deal to really work. What you saw yesterday is just the front end, but in the back end, a lot of work was put into this. So this is an overview diagram for digital twin that you saw the demo yesterday, and also the another demo will be carrying out tomorrow. So we have all the components put together, and the whole idea is to facilitate the development of future applications. So we are trying to build a platform, and this platform should be usable, plug-in, ready for other potential applications. One of the key ideas that we put forward is to enable the collaboration between researchers and industrial partners, which is currently the prime focus for us to moving forward to the marketplace, try to see if we can share our 3D assets. We can use other folks' 3D assets. LIST has a lab building 3D assets that could be shared with the public safety community, and we're also trying to do the same thing. And also we want to build a test bed that could be utilized for testing some products. But again, it's something ongoing. It's not done yet, but I think that's the plan for the phase 2 of this project. So essentially, this is more or less like the more generic platform that we are trying to build based on the work we have done for the digital twin scene. You may see this whole diagram as a separation from left and right. To the right there, that's a virtual platform we are building just based on all the lessons we learned. Essentially, when we're working on the digital twin project, it's not necessary to have a physical twin ready. For us, it's convenient because we have a disaster city, but for many other folks, we are trying to build something to look into the design and planning. You probably don't have any physical facility, which is quite expensive, as you may expect. So the Water System platform is helping you to test things out by sending the water images, water messages through the MQT broker, which is the ISO standard documentation and standard protocol, and similar to TCP, IP, HTTP that you can use to share messages, and very commonly used in IoT community. So we are using that. We're using the open source platform, M2X, and our backend, and we use the TV engine for time sequence data, all the open source tools we are using for all the information we are doing in the backend. So I would say for now, this seems to be working fine for us. And for all the new plugging into the system and also for communication with the tag and automatic use of yesterday are mostly through the activity broker we are building based upon this EMQS platform. So the whole idea is to build a standard-based platform for this facilitate the development of digital twin for future projects and also facilitates the communication with other vendors and also researchers. To the left-hand side, that's our research. We just organized super reduced order modeling platform, which is usable for a lot of things. You don't want to mind about reduced order model, the term here is just one way to simplify more complicated physics-based models and using some linear algebra transformation methods to make things simpler. Even though you're not directly reflecting all the physics and all the mechanics behind it, but you can use reduce all the modeling method to make things running faster. It's more or less like free transformation to some extent, but you get rid of all the high frequency noises, you get low frequency main components, get everything reconstructed, and you get the main signal reconstructed. So we are doing this for not only solving the very complicated part of different equations, but also for time sequence reconstruction and many other things, which is a very helpful research area in the community, and commonly used for building up model for twins. On the front end, we have our folks, our students, working on the 3D model reconstruction based on images, videos, and they did work on the geometrical remodeling, which is like a standard way of doing this 3D modeling, but to get a high resolution, high fidelity 3D model, you have to do that more or less. But the current technology, as a Gaussian spline twin, some of the fan neural network is working, but it's not there yet for you to get high fidelity model like we saw yesterday and tomorrow. But we are working on that. So on the predictor side, basically we build digital twin. The predictive ability is one of the most essential components. Getting the information from all the IoT sensors and all your cloud knowledge based on the physics-based models, those are providing the input or the fundamental foundation for your predictive model, but you need to put things together. So I have been talking with my students many times. There's nothing new here for digital twins. It's just a combination, a new paradigm for us to put things together and just look at the things from different perspectives. But the fundamental models and the sensoring technology are from all the vendors, from the cloud technology, from all the standards. We're trying to follow them, but we're just trying to figure out a better way to organize everything together and give you a very nice overview about the information you're collecting and give you some insight into the future direction. So that's the basic platform we are currently working on, and a lot of students on my end are working on the user interface and 3D modeling. They're building the fancy front end. There's a couple of postdocs and research scientists coming working on this environmental modeling stuff. That's our core here. That's a primary research component. So lastly, I want to put a plug in for this IEEE public safety initiative. I was involved into this community again a couple of years ago when I started working on this project. I got a call from the IEEE member, and he's organizing this committee for the public safety initiative. So I joined the testbed committee as co-chair, and also we have today we have IEEE Move Truck program lead Grayson right now, and also team. I'm sorry, your last time I don't remember. So they are here, so they will be showing you the IEEE Move Truck. We will be part of the IEEE testbed, public safety technology testbed. So they have a communication devices, they also have a power generator and many other things that will be essential to help with disaster relief and other things. So we are working together on another pilot project to work on a digital twin for the truck. So the idea is that the data they'll be collecting when they're going to different places to help with different communities, the data, communication data they're collecting will be shared with us, and we will be sharing with the community through some ways. And we've currently worked out the detail and find get proposals submitted to IEEE, also to the Next Science Foundation. So that's the ongoing work. And you will see the truck tomorrow, I assume, and see the other city. And you can get in there and talk with Grayson and the team and figure out the best. So with that, I think that concludes my talk here. So thank you.
Darren. Next up, we have Darren Levinson.
Good morning. My name is Darren Ludington, and I work as the Regional Vice President of Sales for IDirect. I didn't have slides today, so I'm just going to talk a little bit about what we do in first responder community, and then a little bit about how our company is advancing on one of the topics that John mentioned in his initial video. IDirect is a manufacturer of equipment to build out satellite networks. So a lot of user terminals, when you see the first responder and disaster recovery fleets by most of the telcos, many of the sponsors here today are users of our technology. I have a very close and privileged relationship with the Verizon Frontline and Satellite Solutions Group. I've personally deployed for the past 4 hurricane seasons. We as a manufacturer felt like the best way to see what's going on in the field and learn how our technology responds. Again, at the heart of the Hawaii wildfires and hurricane season, California wildfires, was to be there embedded with them, with the first responder teams that are going out and supporting these networks. So that was kind of the perspective we took, and it's been incredibly valuable for us as a manufacturer, again, to look at what's being used, how the technology is being deployed. And then again, if we look at many of the Verizon assets that are here this week, I'm spending my time here with them, with the Verizon team. And the network infrastructure that they've built out to be, again, first on the scene and reliability. So they've got 3 satellite uplink facilities across the continental US, using multiple geostationary satellites, so different providers, different amounts of bandwidth. And what that is able to do, when you saw some of the Starlink data, Starlink as a supplemental technology in these disaster recovery scenarios is great. It's a great additional tool. But what you have with the telcos and Verizon's first response group is dedicated resources. So when you look at LEO terminals that are individually placed single points in a network that's controlled by somebody else, the deployed satellite solutions from the Verizon team and Verizon Frontline specifically are, again, dedicated resources. So there's control of the QoS mechanisms. There's control of what equipment in the field and what coverage gets those resources assigned to them. So you really have a much more fluid and predictable network performance when you need it. Okay. The disaster scenarios, especially for hurricanes, are extremely interesting. One of the things that I found most interesting the first time I deployed with the team was the length of the stay, right? So within the first few days, columns start to come back online. The towers that were damaged have a satellite backup system and they come back online. But then you see as the linemen come in, and again, the linemen crews from around the country that come down to each of the disasters and help get electricity reestablished, they don't care about the fiber. So the first few days, the network looks one way, the sites get reestablished, but then as the electrical workers go through and start to reestablish power, the fiber optics often get cut out. So towers that survive the storm and are operating fine, a week later, 2 weeks later, 3 weeks later, will go out of service as the linemen again are reestablishing power. So that was one of the most interesting things from the first deployment that I saw. So the teams, these guys that are going down and living in campers and being, again, first on the scene, a lot of times they're almost the last ones out because they've got to be there keeping the networks up, not only for first responders, but for public use and just making sure the 4G and 5G networks are stable. So that's a little bit of my experience, again, with the customers, and I think many of the people in this room are users of our technology and have used it at one point or another, whether you know it or not. The IDirect brand is pretty well known, I think, in this community. So what are we doing to change and keep up? And going back to John's initial video today, he talked about virtualization, and there were some mentions of cloud services. So our next gen platform is called Intuition, that was recently launched, and we're building out the kind of the first release of that soon. But a lot of what you'll see from the VSAT manufacturers is ways to make the terminals more dynamic, ways to make them more easily deployed. So on the hub side, the infrastructure core side, there's a private cloud version of the network management system. So being able to take the network processing and network management into virtualized servers, virtualized instances of servers that don't necessarily have to be a physical server placed where the hub infrastructure is. So again, I mentioned the Verizon network, 3 distinct teleports around the US, but you can virtualize those services and be able to move the computing power where you need to. So as demand changes, again, whether it's a California wildfire, Maui wildfires, or something on the Hurricane Ian in Fort Myers, you can move those processing needs around the different teleports as more of the services are virtualized. On the terminal side, IDirect is part of two different consortiums. One is called WAVE. These are the IEEE level. One is WAVE, which again is focused on virtualization of the services and how to move more of that computing power into the cloud, either private or public cloud. A lot of the customers in here in this room and across the US DoD market, they don't ever want anything to touch the public cloud. They will use private cloud services to again take advantage of some of this virtualization. The other initiative is called DIFI, and it's actually a standard that we're trying to push the entire industry to that would virtualize the interfaces for the modem. So today, most of your typical satellite modems have coax cable interfaces where you have to connect from the modem up to the transmitter and receiver that are located on the antenna. That means we have to manufacture a very specific piece of hardware. And when there's a disaster, a high-grade project, just any kind of demand in the field, manufacturing problems after COVID, we've got to manufacture a specific piece of equipment that then needs to be manufactured, packaged, and shipped. What DIFI will allow is virtualization of the digitalization of the interface so that we don't use the traditional L-band coax cable connection between the modem and the transmitter and receiver. If those interfaces are virtualized, then that can go over a piece of Ethernet cable. And at that point, then we don't need the specialized hardware, and you can literally load a virtualized satellite modem onto any piece of computing equipment. So a server that's already embedded in a news truck, or the Colts and Cal deployable yacht assets from the telcos, again, can much more easily add a virtualized modem to an existing piece of hardware in the truck. It's again much more scalable at that point than virtualized licensing that goes along with the virtualized modem. Again, it makes the entire rollout and deployment installation of these terminals much more simple and much more easy to respond to changing dynamics. And then the last thing, again, along with the first responder and disaster recovery, one concept that I really like that I saw recently from one of our partners in California is how can we maybe prevent a disaster instead of responding to it? And that one was, and again, John's video had one of the firemen on there, but the project here in the US where there's a very diverse state that has about hundreds of thousands, maybe millions of microclimates. And those microclimates are very sensitive to temperature change and humidity change and the risk for wildfires that come along. So the fire group is actually working with the local utility companies and electrical providers where the IoT connectivity that was also mentioned earlier. So satellite-enabled IoT devices are able to work with microclimate sensors that are measuring heat and humidity for all of these, again, diverse microclimates to predict wildfires. And then together with IoT-enabled substation power grids and again, from the utility providers, they can actually proactively shut off the grid when wildfires risk gets highest and avoid some of the, I think we saw California wildfires several years ago that were sparked by power lines that arced and started pretty devastating wildfires. So they're working together to again be able to proactively turn off parts of the grid where the wildfire risk is the highest and avoid some of the disasters instead of having to respond. Thank you.
All right, before we close out, we can't end this kind of discussion without some words from Walt, since he's been working on Interop for many, many years. It's been a close partnership with DHS.
Okay, so John asked me to go ahead and kind of do a cleanup on the session to kind of bring things together in terms of what we're doing here at the Institute this week. So if you look at it, obviously we've got the first responders out there and the researchers out there doing all kinds of really neat advanced things and everything else. And I think we all agree that the networks that we have today in place are good, they're great, they should be used as a primary service and everything else. But the reality is they don't meet all the requirements we've got today. You know, Robin is talking about needing, was it 60 gig over 1 hour? Good news is our satellite service can be 50 gig per month. So about 50 minutes into this process, we will have run out of capacity. So what we end up doing here at the ITEC, and especially for the Institute, is we look at it and say, all right, where are the technologies going? How can we start to figure out how to use them? How can we start to figure out how to test them? Because realistically, at the end of the day, we've got to operationalize all of this stuff. So we want to, we really have two primary goals and things that we look at, we're trying to do this. One of them is, can I make it Robin proof? Okay, no matter what I send her out in the field with, she's gonna break. So can I set it up to where a first responder can go ahead and actually operate it seamlessly? Can I also then go ahead and make it simple? So for example, on this iPhone here, we've got the ability to go ahead and support our local private 5G network and also the service provider's 5G network. To do that, I can go into the settings and I can switch back and forth between networks. How likely is it that a first responder is going to go out in the field and actually end up doing that? So there's a couple of ways we can get around that. One of them is working with companies like Qualcomm, who's trying to basically put the decision making in the chipset so it's transparent to the first responder. The second way is actually integrate the networks. So could we go ahead and do things like take the private network where you need it and the public network where you have it and set it up to where it can go back and forth between the field. One of them is using a technology service provider has been doing for a number of years, things like Moken, where, for example, AT&T supports Cricket. Cricket is a separate network. Well, what we're hoping is that if we build some of the private networks ourselves, for areas that we know are critical to us and are harder to reach by the service providers, can we go ahead and then actually have it set up to where we see their network on our private networks, and its first responder doesn't have to do anything. They're in the building, they're on the private network, out of the building, I'm on the Verizon network. That's the goal, that's the vision. The challenge we've got in doing that is typically 3GPP builds stuff like that in the standards. So the capabilities all exist. But generally what's happening right now is we're working on R20 or R19 and R20 in the standards body. Once the standards bodies complete that, then it goes to the Nokias, the Ericssons, and the Samsungs, and they build it and put it into their platforms. That's another couple of years. And then the AT&T, Verizon, T-Mobiles have to get that throughout the nation network or world network or US-wide. You're looking at another few years. So realistically, what we're trying to do here is figure out what are the capabilities going to be, how are we going to leverage them, how are we going to use them, and in essence, that gives us, a lot of what we're seeing here will give us direction as to what we're going to be doing next year. It would be great to have it all available on the network today and figure it out, but the reality is that if we wait until the service provider actually provide it for us, again, they have to build a large, huge, expensive network. It takes them time to go through these iterations. So what can we do to really figure it out ourselves? That is the primary goal of the Interoperability Institute, is to figure out where are we going, get it, work with our partners, work with the first responders, that tomorrow they'll be actually validating some of the concepts that we'll be using in a few years. So, we've got, every time we do one of these, we see more and more and more opportunities. This is an opportunity-rich area, okay? There's a whole lot we don't know. So, let's keep doing it, go on bigger and better for next year. Generally, what we do is about a month or so before this thing is actually held, we sit there and we transition over to next year. When somebody comes up with a great idea, 30 days in advance, our answer is Interop 25. Okay, so you can't do stuff like this. You can't do stuff like this overnight. So all I had, John. I think you probably want to have the group ask some questions for everybody.
Before we go into that, I love that term, make it Robin proof. And here's why I say this, is that I've been through a number of operational exercises which have been led by DHS. And other staff members from DHS will know, my ultimate goal is not from the perspective of just making sure everything works correctly. My goal is to make sure and figure out a way to break it. And the reason behind that is that the last thing you need is from the responder perspective, when they're responding to a major incident, something goes wrong. You need to try to figure out what those things are well prior to the event actually occurring. We've run major exercises in the course of the last 5 years by Sridhar, Wong Lu, and others from DHS, which included over 200 to 300 responders from just about every discipline. Major exercise ran, I think it was about 3 years ago, possibly. Sridhar, I think it's down in Harris County, Houston, Harris County, over a period of 2 or 3 days. The goal was to run through a number of scenarios. We developed what we call a MESL, event scenario list, to identify specific areas that the responders had identified were issues. And based on those, we go ahead and we test it. Take this as a learning opportunity when you solve it. You test out your equipment. If something goes wrong, great. It's an opportunity to change things on the fly or go back, do a little bit more research, make the correction. With that, I'll turn the floor over. I think we have a few minutes. So we can take 2 or 3 questions.
John, you're here somewhere. Yes, you had a slide up there with the TD engine as the database, which you're using for the. Could you review some of the aspects of that database?
Yeah, it's a relatively new database. It's called TD engine. And it's kind of similar to InfluxDB, some of you probably already familiar with. As TD engine has been optimized to be really, really flexible and high performance in terms of time sequence data. And it's really scalable. And also it's it's open source, and we have been trying out different time sequence database in the last just 2 years. We started looking into InfluxDB. It's working well, but it's just for some time it didn't work as we expected. There were some performance problems on some of the smaller computers. The TD engine get just working right away, and we started looking into the benchmarks and done by people in the IT world. TD engine seems to be doing pretty well in all those benchmarks. So that's why I just picked it. Again, switching from TD engine to InfluxDB and other time sequence database is straightforward. It's just like, we pick it, use it, and make it easy for us to make a container and ship it to different machines when we want to use it. So that's on the IT implementation side. And it's just, that's the choice we made.
Is it just geospatial points with a series of attributes associated with each one?
It's just very simple time sequence, timestamp and value. And that's exactly what it's designed for. Simple, straightforward, and it's easy to maintain and scalable.
So how do you deal with the geospatial element of your database?
So that's one we rely back to Postgres database, which has default supporting for geo references and other shape files, and that's what we use for regular analysis. But for the typical twinning, all the coordinates have already inside our gamma engine. So we have all the measures, we are referring to the local coordinate system. So we are not adding special queries directly into the typical twinning platform itself, unless if you want to do a web-based interface on top of the backend, you can have some database. But for the game engine-based interface, we don't have that very complicated special queries.
I was going to grab the mic for a second if I could. So, so there's 2 other projects that the Public Safety Communications Research Group out of Boulder, Allison's here representing NIST as well. There's 2 other projects that are related to this project. Gian is co-PI on both of them. One of them is what we call the AI3. AI3 was a challenge where we ended up putting together a competition for teams to get together and figure out, how do I look at IoT data? How do I normalize it? How do I secure it and everything else? And kind of the core of that ended up being an MQTT broker as well. But then in addition, we also have been working with Rob on some, yesterday we was talking a little bit about the information sharing framework. And again, for the IoT stuff, we're using MQTT broker there. So Gian has really become an expert on how we can go ahead and normalize and secure the IoT data, because they keep talking about IoT sensors going right straight into 911. Not until we can normalize and secure it is that gonna happen. We also talk about it, for example, getting it in the hands of the first responders. Again, the same issue. IoT right now is kind of the wild west. I'm not gonna log on to Ring's webpage to try to find somebody's camera, and as I said, I mean, first responder's not gonna do that. So we have to figure out better ways. And we had 2 winning teams on the AI3 competition, so and did some fantastic work there. And both of them are companies that will hopefully be releasing their products all of you soon as well.
Any other questions?
Great, thank you, John. That was fantastic. Okay, so the next keynote starts at, or actually our keynote address starts at 10:05. Right now I've got about 7 minutes until 10. So we've got until 10:05. So please enjoy refreshments out there and visit with our technology partners out there, and we'll see you back here at 10:05.
See what I'm doing.